drawn up here, and it's a picture of you. Picture of you. And many people don't realise what's happening inside of their body, but what's happening inside of our body is indicated by what's happening outside of the body. In fact, our hair, our eyes, our skin, our sight, our hearing, all are an indication of what's happening inside of the body. And many people are unaware of what goes on in there. So what I'm going to do tonight, I'm going to take you on a journey. And we're going to start at the mouth, and we're going to go all the way through the gastrointestinal tract. And I'm going to show you that amazing process that changes the food that we ate at lunchtime today down to tiny microscopic particles that then get absorbed into the blood. Now, at any point in that journey, if digestion is not running as it should, that basically can inhibit the proper transfer of those nutrients into our blood, and thus affect our ears, eyes, etc., our hair, etc., etc. So let's begin. And all the food that we eat goes in one place, and that is the mouth. Now, in the mouth, this is the only place in the whole of the digestive tract where we have say over what goes in, we have say over when it goes in, we have say over how it goes in, we have say over the environment around us when it goes in, and we probably all know that that certainly affects digestion if we're eating in a rush, or if we're eating under stressful environments, or if we're eating in a pleasant, peaceful environment. That actually affects our digestion. We also have say over how long it stays in our mouth. And did you know that the only part of our digestive tract that has teeth in it is the mouth? And so we should chew, 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 chew. In fact, it is said we should chew 30 times, because if we don't chew our food up properly, there's nowhere else where it's going to be chewed up. And when we chew our food properly, we break it up into tiny little particles, and that's a larger surface area for our digestive enzymes to be able to work on. Also in the mouth, when we chew, 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 it basically mixes the food with some digestive enzymes in the mouth. Now, there is only two foods that are digestion starts in the mouth. So first of all, let's have a look at the mouth. That's the first organ we're going to look at, and the mouth pH is alkaline. And the enzyme that starts working on the food in the mouth is ptyalin. And ptyalin is an enzyme that breaks down starch, or another word for starch is carbohydrates. But let me tell you something interesting about the starch that is broken down by the ptyalin. There is no ptyalin in the mouth of a baby. And the first teeth that a baby gets is 4 at the top and 4 at the bottom. And those 8 teeth are called milk teeth, because that's all babies should have. Milk. Now, there's a misconception today that babies should start eating food between 4 and 6 months of age, but it defies reason. How can a baby eat food if it has no teeth? Am I right? And you know there's been a death and no one attended the funeral because no one knew he died. It was the death of common sense. Are you interested in lying down and being fed slop? Isn't that what people do to babies? Now, when a baby sucks the nipple or the teat, they suck with their tongue and their top lip like this. And if a baby has no teeth, and the mother, because she's been told to feed the baby food, she has to blend it all up and make it like slop. And she puts it in the baby's mouth, the tongue and the lip meet, and what happens to the food? It comes straight back out. And I know when I had little ones, people used to say, Barbara, you just keep scooping it up and shove it back in. That defies reason. It defies reason. So babies should not eat any food till they can sit upright, till they can actually get the food and put it to their mouth. But that's not enough. The baby should also have teeth. But the top 4 and the bottom 4 are tearing teeth. And they're called milk teeth because that should be the baby's main food. And these teeth start coming about 7.5, 8 months, and they're usually through maybe by 12, 13, 14 months of age. But you know, that's a good time for baby to start having little tastes. An apple in a net bag so they can suck on it. A celery stick, or that thick stick from the leaf of the lettuce or the cabbage. They're good things for them to suck on, having little tastes. Or chew all the corn off a cob of corn and give them the cob. And they'll suck away on that for ages, and they're such social little beings that they think they're doing what you're doing, isn't that right? But they should not have any starch until the molars appear. The molars come through back here. And what do molars do? Molars grind grain. And so you see, babies should not have any grain until the molars are through. And when the molars are through, then the glands in the mouth produce ptyalin. No ptyalin is in a baby's mouth until the molars are fully through. When do the molars come through? Between 16 and 18 months of age, sometimes 20 months of age. You know, we have a lot of babies with malabsorption syndrome in the gut because they were fed starch too young. And how many mothers are told, because they say, my baby won't sleep through the night, so they're told, oh, give the baby Farex or rice cereal at night and the baby will sleep through. Baby will sleep through, the baby's knocked out. It's got this lump of glug in its stomach that it can't do much with. I've had four parents email me in the last month. My baby's got constipated. My baby has not gone to the toilet for a week. Have you done something different? Oh, I'm feeding my baby food. What are you feeding the baby? Oh, cereal, bread. How many teeth does the baby have? 2. I said, stop. And then I summarise what I have just told you. The baby has no ability to break that starch down until the molars are through. So they stopped the starch. I said, just put the baby on the milk for now, maybe a little bit of fruit, and then they emailed me back. I got an email today. Oh, in capital letters, wonderful news, the babies. Put up your hand if you've heard this before. Not many, 4. Most people don't know it. Now, most baby feeding brochures, what's on the... You read the back. Who wrote the baby feeding brochures? Heinz Baby Food. What are they going to tell you? If you can start feeding your baby at 4 months, they're going to make a lot of money out of you, aren't they? I never made baby food. Because by the time my toddlers were eating, they could sit, they could chew because they had teeth, and they were feeding themselves. I'll tell you, it's so easy. So easy. So that's the main food that is broken down in the mouth is starch or carbohydrates. So that's your cereals, your breads, your cakes, your pastas, potatoes, things like that. There is one other food that is broken down in the mouth, and it's saturated fat. So saturated fat is coconut oil, palm oil, cocoa butter. You get a bit of saturated fat in your avocado, your macadamia nut, and the animal fats are saturated fat. They're the only fat that's broken down in the mouth. Underneath the tongue, there are sublingual glands, and they release lingual lipase. And lingual lipase is the enzyme that breaks down the saturated fat. So lingual lipase is the enzyme that breaks down saturated fat, and the ptyalin, the starch. They're the only things that are broken down in the mouth. So make sure you chew your food well so they can. Then we come down into the stomach. So the next organ we're going to have a look at is the stomach. And the pH of the stomach is acid. It's the only part of the body that should be acid. If someone says, I've got a very acid stomach, I say, fantastic, it should be. Now there's only one food group that's broken down in the stomach, and that is protein. Nothing else is broken down in the stomach. Starch digestion stops in an acid environment. The saturated fat, it basically just plods along with a little bit of a breakdown. It is protein that's broken down in the stomach. So let me show you how this happens. The stomach is lined with huge big folds like this. And around the folds are gastric glands. And 3/4 of these gastric glands release mucus. And what mucus does is it causes a thick mucosal lining to protect the stomach. Down here, these little glands down here, they release hydrochloric acid and they release pepsinogen. Now that release can only happen in a very acid environment. That's why it's important not to drink with your meals, because if you drink with your meals, you'll water down your hydrochloric acid. So they're only released in an acid environment. They connect and activate pepsin. And so it is pepsin that breaks down protein. But pepsin can only be released in an acid environment, and pepsin will only work in an acid environment. Most people don't realize that's the only thing that happens in the stomach. Now something else is happening in the stomach. These are called the parietal glands. The parietal glands release the intrinsic factor. So I'm going to give you a little description of what happens with B12. B12 is bound up in food. And when B12 gets into the stomach, the hydrochloric acid breaks the B12 from an R protein, releases it. And then as it goes further down the small intestine, B12 and the intrinsic factor unite. And then about here in the last part of the small intestine, B12 is absorbed. But it can only be absorbed if it's linked with the intrinsic factor. B12 is an airborne bacteria, so you'll find it on homegrown vegetables, you'll find it in rainwater, you'll find it in organic root vegetables. A lot of people don't realize that you can get B12 there. Now, there is an enterohepatic circulation that happens with B12, and that goes through the liver and back here, through the liver and back here. And most of the B12 that we eat in food is recycled. So someone can have no B12 for 30 years and not show a B12 deficiency. So why do people get low B12? It's because their gut isn't working properly. They don't have enough hydrochloric acid to break the B12 and the R protein, and they're not releasing the intrinsic factor. Can you see why? Where can I put it? My big why. Can you see why people suffer from low B12? Meat eaters and vegetarians both alike can suffer from B12. I hope I didn't lose you there. Stay with me. So that's what happens in the stomach, is the protein is broken down by pepsin. Let's move on. We're going to go now through the pyloric sphincter. And the pyloric sphincter is the little valve at the end of the stomach. When we wake up in the morning, it's open. That's why it's so good to drink warm water in the morning. You drink ice cold water in the morning, pyloric sphincter has to shut and the stomach has to warm it up. Did you know that? Before it can go any further. It's a good time to drink your water, is before your meal. As soon as you smell, think food, that pyloric sphincter shuts. The glands in the stomach start producing the enzymes, as do the ones in the mouth already. Now, something happening in the mouth, when we keep the food in the mouth till we've fully chewed everything up, what's happening is the brain's getting messages. Oh, there's a little bit of fat in there. Oh, there's a little bit of protein in there. Oh, we've got a bit of starch in there. And then the brain starts to alert the other organs down below. We've got a bit of starch coming, we've got a bit of fat coming, we've got a bit of protein coming. If you chew quickly, I was in a restaurant one day, and the lady just opposite from me, I couldn't help but notice it was chew, chew, swallow, chew, chew, swallow, chew, chew, swallow. Do you know what's happening with that? The organs are saying, what's coming, brain? And the brain says, I don't know. I don't know. What was that? What was that? Oh, I don't know. Can you see how important it is to chew? Chew. Chew. In fact, if you're in a rush and you're hungry, you're better to buzz yourself a smoothie and drink that down rather than eat in a hurry, and poor digestion's not going to work that well. So the stomach, as you can see, it needs time. It needs your mouth to have chewed everything up properly. And what the research shows is that digestion averages 3 to 4 hours. And then the stomach loves a rest of 1 hour. So what does that equal? That equals 5 to 6 hours between meals. And what do many personal trainers, nutritionists tell people to do? Eat every couple of hours. Well, you see, this pyloric sphincter, it has sensors. Now, let's say breakfast comes in. There it is, chomp, chomp, chomp. When it starts to get broken down to the right state, the pyloric sphincter opens, and little by little the food starts to come through. And let's say 10:30, 10 o'clock in the morning, morning tea. Maybe it's a biscuit and a cup of coffee, maybe it's a cake and a cup of coffee, maybe it's a pasty, a sandwich, a pie, or maybe the person's really healthy and it's an apple and a handful of nuts. Whatever it is, comes in, pyloric sphincter gets the message, quick, something's just come in and it's not broken down, shut the gate. And it remains shut until this gets broken down. Maybe it'll take an hour or so and join the other. Then pyloric sphincter opens, and little by little bit more goes through. And now we're at 12 o'clock. What's happening at 12 o'clock? Oops, lunch comes in. Shut the gate, something's just come in and it's not broken down. Can you see what happens? And research has shown that at the end of the day, there can still be some breakfast in the stomach. Now, have you heard of Michael Mosley? He's famous for the 5-2 diet. He's written a book called Fast Diet. And he basically looks at this. He says, what's going on today? When I was a kid and I was hungry an hour before tea time, what were we told? Wait for dinner. He says, now it seems like kids are just fed all day long. And then the parents wonder why they won't eat their meal. You know, no child dies in Australia, New Zealand from starvation, do they? And the whole thing is, when that stomach's empty, as you'll see, the food is still being absorbed all the way down the track. So we should eat breakfast like a king. And the main food groups, the essential food groups, are fibre. What fibre does is it holds up the glucose and slowly releases it. We should eat also good amounts of protein. What's your proteins? We've looked at a bit this week. Your legumes. We're going to show you how wonderful legumes can taste for lunch tomorrow. Also your nuts and seeds. And healthy fats. What are your healthy fats? Fats that came from the hand of the Creator in the form of seeds and nuts and your olive oil, coconut oil. Concentrated foods, you don't need very much, but we certainly do need them. These are the 3 food groups that keep the food in the stomach longer. These are the 3 food groups that will allow you to go the distance between meals. So lunchtime today, it was 1 o'clock, I think I had lunch. I had what's called idli. My Indian hosts made it. It's made of rice and dal, and then we had a kidney bean dal as well. And then we had lettuce and avocado and cucumber and tomato. All of that food has fibre. My protein is in my dal. There were a few nuts and seeds in the salad. What were the fats? There were some healthy fats in the dal, in the avocado, a bit of olive oil on the salad. Can you see that all it is? So what's the time now? It's about 6:20. I have no hunger. I am not hungry. Now, if I get a little bit hungry after working hard tonight, last night I was very hungry when I got home, so I had a kiwi fruit and a banana. So it's something very, very light, just something to take the hunger pangs at bay. But if I hadn't worked hard last night, maybe I wouldn't have needed anything. That's why we should eat breakfast like a king, lunch like a queen, tea like a pauper. Because when we go to sleep, that stomach wants to sleep. That stomach needs rest between meals. The rest between meals allow all the glands to replace the digestive enzymes ready for the next meal. And tomorrow morning, I'll wake up early and I'll probably be hungry and I'll have a big glass of water and then I'll do my exercise, I'll have more water. I had a hot and cold shower this morning. Your cold is cold. Whoa. Aren't you glad it's quick? Your laugh tells me you've all tried it, right? That's why your cheeks are so rosy. And you see, when you give the stomach the right condition, it will work well. It needs to work and then it needs a rest. So as we go through the pyloric sphincter, the food now comes into the duodenum. The duodenum is the first part of the small intestine, and I hope you can see my drawing. So in this duodenum, we've got the liver, there's the gallbladder. The gallbladder is a reservoir for bile. And then the bile comes down this little bile duct and comes into here, and that helps to break down some of the food, which I'll show you. Then we've got the pancreas, and the pancreas is also releasing some enzymes. So now we're into the duodenum, and the duodenum is an alkaline environment. Now, to ensure that it is an alkaline environment, the pancreas releases sodium bicarbonate to help neutralize that stomach acid that comes through with the food. So let's have, first of all, look at the gallbladder. Now, if a person has had their gallbladder taken out, they will still be releasing bile because it's the liver that makes the bile. The gallbladder is a reservoir. So now we're looking at bile, which is released from the gallbladder. And what the bile does is it breaks down polyunsaturated fats. It's the saturated fats that start in the mouth, but it's the polyunsaturated fats that are broken down by the bile. So they're all the fats that are found in your nuts and your seeds. And now we've got the pancreas. So the pancreas is the next organ that releases into the duodenum. So the pancreas releases pancreatic lipase. Now lingual lipase breaks down saturated fat, whereas pancreatic lipase breaks down polyunsaturated fats. So what happens is the bile breaks the fats down to tiny particles, and the pancreatic lipase further breaks it down. So then it can be absorbed into the villi, into the blood. Now what the pancreas also releases is pancreatic amylase. Ptyalin is an amylase. Amylase breaks down starch. Now remember, with starch started in the mouth, was partially broken down, put on hold in the acid stomach. Now it comes through to the duodenum, once again in an alkaline environment, and now the pancreas releases pancreatic amylase to further break down the starch. Now, in food, you've got polysaccharides and disaccharides. Now, polysaccharides just means many sugars. Disaccharide means 2 sugars. Monosaccharides, 1 sugar. So what happens is, in food, we've got polysaccharides, many sugars. And then maybe in the mouth under ptyalin, it's broken down to disaccharides and polysaccharides. And then when it comes down into the duodenum, pancreatic lipase breaks the disaccharides down to monosaccharides, and the polysaccharides down to monosaccharide and disaccharide, then monosaccharide, mono meaning 1. Only that single structure can be absorbed into the blood. And the 2 main monosaccharides are glucose and fructose. So even though they sound like big words, if you break them down, they're not that hard to understand. There's more. And believe me, this last one I'm going to show you, there's no more really big hard words. Okay? Pancreas also releases pancreatic enzymes, and it's called trypsin. And there's another one that it releases called chymotrypsin. And chymotrypsin and trypsin are the 2 enzymes, trypsin, that break down protein. Now remember where protein started to be digested? In the stomach. So the digestion begins in the stomach, and then the protein comes down here, and the pancreas releases trypsin and chymotrypsin, which breaks down the protein. So here's protein. This is what protein looks like. And in the stomach, the protein is broke down to peptides and polypeptides. So the peptides and the polypeptides come down to the duodenum, and trypsin and chymotrypsin break the peptides down to amino acids, and the polypeptides down to amino acid and peptides, and then the peptides down to amino acids. Whew. And it's only as amino acids then that can be absorbed through to the blood. It's quite a process, isn't it? Quite a process. And I've made it as simple as I could. Most people don't realise that the main organ of digestion is what, students? The pancreas. Can you see that? So the starch and the saturated fat start in the mouth. The stomach, all it does is start the protein breakdown. But when we get into the duodenum, gallbladder starts the fat, the polyunsaturated fat, but it is the pancreas. The pancreas finalizes fat, finalizes starch, finalizes protein. Most people with pancreatic cancer die of malnutrition because they can't break their food down. That's why if someone has pancreatic cancer or pancreatitis, they should go on digestive enzymes to help break down the breakdown of their food. In my next lecture at 7:30, I'm going to go through the gastrointestinal tract again, and we're going to have a look at every stage how you can bring about healing. Well, students, we've now come to an auspicious time which is called the grand finale of digestion. So we're down in the duodenum and we're coming down into the small intestine. You see here, let me draw. The lining of the small intestine is lined with little villi. And up in the middle of the villi is a lacteal, that's part of the lymphatic system. And all through the villi is the little capillaries carrying your blood. And covering the villi is a thick turf wall. And that thick turf wall is made up of bacteria and a few yeasts. It's called Lactobacillus acidophilus bifidus bacterium. There's a thick turf wall covering the villi. And that villi play an important role. Their covering is what does the final touch, as I said, the grand finale on digestion. These bacteria are responsible for the final breakdown. In fact, that bacteria is responsible for releasing the B vitamins. And that's why sauerkraut, miso, yogurt, all your cultured foods, they release B vitamins. And the combination of Lactobacillus acidophilus and wild yeast in those cultured food is very similar to also the combination of wild yeast and bacteria that is in our gut. In fact, one nutrition was a professor of nutrition. He said there's a literal jungle down there. There are 10 times more microorganisms in the gut than anywhere else in the body. And they play a very important role. They are responsible for the final breakdown of our food. They are responsible for the absorption of our food. They are responsible for protecting our blood against harmful pathogens. And they are responsible for nourishing the cells that line the gastrointestinal tract. So there's the grand finale of digestion that is accomplished by the thick turf wall lining the gut. Now let's say someone has a compromise in that thick turf wall. What would compromise it? Antibiotics, statin drugs, contraceptive pill, cortisone, or your steroid drugs, a lot of your painkilling drugs. Now we've got some gaps in that thick turf wall. And wherever you've got those gaps, you've got a compromise in the final breakdown of your food. You've got a compromise in the absorption of the food. You've lost your border protection. That's your border protection. So harmful pathogens can come out of the gut and get into the blood, and the cells that line the gut have lost their nourishment. Ooh. In my next lecture, I'm going to show you how you can build that up. But I want to show you something else a little bit scary. Now, this cell just here is a very happy cell because it's got nourishment from that flora. But this cell here is a very unhappy cell because it has no nourishment, because there's no gut flora there. The hybridized wheat, when it is eaten and breaks down in the gut, breaks down to a substance called glutamorphine. What's morphine? It's an opiate derivative. Also, especially the altered milk that we see today, the dairy milk, especially in a gut that can't handle it, it's broken down to caseo, morphine. So for purposes of illustration, here's your glutamorphine. Here's your caseo morphine. Let's have a look at what happens. Glutamorphine comes along here. Happy gut cell has the ability to knock off the morphine, so only gluto gets in. Caseomorphine comes along. Happy cell, healthy cell, can knock off the morphine, so only caseo gets into the blood. Let's come over here. Glutamorphine comes along. This unhappy cell does not have the ability to knock off the morphine. And so glutamorphine comes into the blood. Same with casomorphine. Casomorphine comes into the blood. The blood takes it to the brain. The opiate receptor sites on the brain pick it up. And these can contribute to mental illness. There are 2 books, if you're interested in pursuing that line. One's called Gut and Psychology by Dr. Natasha Campbell McBride. The other one is called Grain Brain by a neurologist called Dr. David Pert Muller. And he cites in his book psychiatrists who take their schizophrenic patients off wheat, off dairy, 50% improvement. Also Bruce Fife in his book Stop Alzheimer's Now, he shows that it can improve an Alzheimer's mind by stopping the wheat and the dairy. Stop Autism Now is his other book. And Jenny McCarthy, apparently she's a movie star, she wrote a book on how she conquered her son's autism. When she stopped the wheat and the dairy, 50% improvement. So can you see what's happening here is that it's just not the hybridization of the wheat and the changing of the milk, it's also the state of the gut. And Dr. Andrew Wakefield, I call him Dr. Andrew Wakefield. He's lost all his credentials now because of what he did. He's a gastroenterologist from England, and he noticed that a lot of children coming to him with gut problems were also autistic. They also had problems in their brain. And so he did biopsies on their Peyer's patches. Your Peyer's patches are here in the colon. Did you know that your immune system is established by your gut flora? And these children had compromised guts and autistic, and he found traces of the MMR vaccine in there. So he wrote an article in The Lancet, not against vaccination, not against drugs, just saying, isn't it interesting? I found that these children with compromised gut flora also had brain problems. Do you know the pharmaceutical company did a witch hunt on that man? He lost his credentials, he lost his job, he cannot even get a job in England now. He said, I'm not against vaccines, I'm just telling you what I found. He was the head of a whole team of pathologists who were finding this. You can read his book, it's called Callous Disregard. Why did he call his book that? The gut, what's harming the gut? That's what you've got to look at, is what is harming that gut. Because when you get in a compromise in the breakdown, a compromise in the absorption, a compromise in the protection, a compromise in the nourishment, I've just given you a little bit of an indication of the problems that can arise. And again, there are many books written on this that you can pursue those things. Whew. Now, if we haven't got a compromise, if our breakdown, absorption, protection's working well, our food gets absorbed through to the blood. Now there are little receptor sites here for the different food that's coming through. Let's have a look at the one for glucose. There's a carrier that carries glucose through to the blood. But the carrier says, I will not accept you glucose unless you come with a molecule of sodium. And that's why it's so important to have salt with your food. Because when you eat salt with your food, and by the way, doesn't it make food taste nice? Our palate tells us we should be having salt. What's a baked potato without salt? And I can tell you lentils are no good without salt. But as I showed you last night, there's salt and there's salt. We need to take salt the way it's found in nature with all of its minerals. So that's your Celtic salt or the Himalayan salt. When the sodium's present, then the carrier will take the glucose through to the blood. Your saturated fats, they go straight through to the blood too. They go up to the thymus, then to the liver, and they're burnt as fuel. Whereas your polyunsaturated fats, they get absorbed through to your lacteal, taken up to the liver, and the liver stores your polyunsaturated fats in your nuts and your seeds, because those polyunsaturated fats are used exclusively for cell membrane and repair. So you can see the grand finale of digestion is dependent on a few things. Now, by the time we get down to that last part of the small intestine, in fact, halfway through, all the nutrients are absorbed. And as I showed you previously, it's right at the end here in the ileum where the B12 is absorbed. When the contents of the small intestine comes into the large intestine, it's basically liquid. So one of the main functions of the large intestine is to take water out so stools are formed, so that when it comes through this end, it has form. And here is the appendix. Did you know that God didn't make a mistake when he put that there? The appendix has an important role to play in the functioning of the colon. The appendix is called the oil can. So what the appendix does, it helps to lubricate the contents to get it through and out with ease. The appendix also releases antibacterial fluid, so that if what's coming out of the small intestine, because it has a lot of sugar with it, and by the way, meat putrefies, so by the time it comes out, it can be pretty toxic too, and so the appendix releases a lot of antibacterial fluid to try and calm that down before it comes out of your body. So one of the main things for the colon is to take water out and move it through. Now you'll notice there are lots of little grooves and corners in our colon. It needs to be swept every day. What sweeps the colon is fibre, and the highest fibre food is your vegetables. Vegetables are high in fibre, high in minerals, low in sugars, whereas your fruits, high in fibre, high in sugars, and low in minerals. So your vegetables are more your healers. And as I mentioned earlier in the week, the best food for people conquering cancer is to veer more for your vegetables. There's all your fibre. All your plant foods have fibre. Meat has no fibre, and it is known to get caught in the little crevices. So anyone who wants to eat meat, you've got to have a lot of vegetables with it to help move it through. Dr. Kellogg, very famous doctor who wrote encyclopedias on health, he said 3 intakes of food a day should equal 3 evacuations a day. He said if a person goes once a day, they are constipated. In my next lecture, I'm going to show you how to move that if it needs to be moved, and I'm going to show you how to slow it down if it's going too fast. Notice as we come through here, we come to a loop in the large part of the small intestine. And you see this little red thing here, it is a muscle. And the muscle holds that little loop up. And how we love that little muscle, because it prevents us from being incontinent. And that little muscle is called puborectalis. And puborectalis is always taut, holding up that little bit so that we aren't incontinent. Now there is a way to open it so that you can pass with ease. So here is the throne. And here is the person sitting on the throne in the morning. Sorry, I'm not a great drawer, but you get the gist. When the person sits, puborectalis is still held up and taut. But if the person puts a little stool in front of the throne so that their legs come up like this in the squatting position, puborectalis relaxes. Puborectalis will always relax in the squatting position. So puborectalis relaxes. That allows the colon to open right up, and the contents are passed with ease. So you can spend $2 at Crazy Clark's and buy a little plastic stool, Or you can go a little bit better and go to, Bed Bath and Beyond? Do you have those shops? And they sell Squatty Potty. That's right. You can be very classy with your Squatty Potty. And Squatty Potty is basically a little plastic thing that sits around the toilet. Sorry, that's not a very good drawing. Something like that. And it can be pushed in when not used and pulled out when used. And many countries today still squat to go. And when I was in Bali, I was walking along the street, and you have a look in the mechanic shop. And all the mechanics, they're fixing the cars like this. And then you walk over to the markets, and all the ladies are sitting like this, and they're talking like this. So a lot of Aussies are not used to squatting, but you can get used to squatting. And if you're not used to it, try squatting. Oops, sorry, I've got stuff there. Try squatting against the wall. And it's usually your thighs that won't let you to. Because when you squat like this. What really grabs is my thighs. So build up your quads. Your quads are your biggest muscle mass in your body, and your femur is your biggest bone in the body. And God made it that way because He meant us to bend, to lift, to squat with our thighs. Now, if you bend like this, no weight is taken on your biggest muscle mass. It's all taken on your lower back. And many people have lower back problems. So when we bend, we should have a straight back, and we should bend like this. Have you seen a little 18-month-old pick something up? They have their legs right apart, they come down like this, and they pick up like that. I watch my little grandchildren, and that's how they pick everything up. And I think, what happens? What happens? Well, we're ladies. And ladies are taught to cross their legs. Ladies are taught to be ladylike. So what you do is just wear skirts like this, or pants or jeans, which makes it a bit more ladylike to be able to do it. So I would encourage everyone to get into the practice of squatting, build up your quads, and you will protect your back. And start to try bending down as far as you can. So I saw a yoga girl one day. She went right down and her head touched her knees without bending her back. So get into the habit of keeping that back straight and building up your thighs. Practice squatting, and also get a little stool or a squatty potty, or my son, he's a builder. He built a nice little wooden one around his wife's toilet. And what people say to me is, they sit to go in the morning and they think, surely I haven't really gone, it didn't seem like it. And they have a little look and it is quite a mound. So it's almost as if it comes out with such ease, because puborectalis relaxes when your knees come up in the squatting position. So if you can't do it with ease, you'll get there. Remember, muscle knows no age. Has everyone memorized that one yet? Muscle knows no age. No matter what age you are, you can strengthen those muscles to be able to do it. Now there's even better news. Once you strengthen your pelvic girdle, which you can strengthen through squatting, through your Pilates exercises, which I'm sure you're going to start doing, you can prevent prolapse of the colon, prolapse of the uterus, ladies, prolapse of the bladder, ladies and men. And you go and visit aged care, or you talk to aged care nurses, and the amount of people in their latter years that have lost that control. And you know what everyone says? It won't happen to me. If you live the way they lived, it will. So my message to you is, all through this week, is start giving the body the right conditions. Start training. Have you seen what the Olympic athletes go to? And they all go to a race that only one's going to win. We can all win this race. We are training for something more important than the Olympic Games. We're training for our latter years of life. I want my daughter Jessica to come out one morning. Maybe I'm 99 like my grandmother. I'm sure I'll be in the garden. Oh, I'm lying on the path. Oh, I'm dead. How nice. Maybe I've got a gardenia in my hand. Do you know, we've all got to die. And not in every case, but in many cases, we choose the way we die by the way we live. As I said, not in every case. There are accidents, there's many things that happen. But it's a good idea. In fact, you can't start early enough. Did you hear that, Sam? Can't start early enough. How old are you, Sam? 9. Good time to start, hey? Good time to start. You can't start early enough. When you look after your body, it enables you to enjoy every age. And as you'll see tomorrow, our brains should never deteriorate. Isn't that good news? The human body will deteriorate, but you're learning how to slow that down. But the human brain need never deteriorate. So everyone who comes to the lecture tomorrow, rewiring the brain. Did you know that you can rewire your brain no matter what your age? And in the afternoon, it's safeguarding, healing the mind, and then preventing depression. They show how our brain need never deteriorate. And that's very good news. But a lot of it's got to do with what we're doing to our body, and a lot of it's got to do with what we're doing inside our body. So this is a good introduction. Now, if a person doesn't squat, a lot of pressure is put on right the end part where everything comes out. And when a lot of pressure is put on there, because of dehydration, because of lack of fibre, because of pressure, horrible little things pop out, and they're so horrible I hesitate to even draw them. They're called piles or hemorrhoids, and I'm just going to rub them out because they're so horrible. You can prevent them, and if you have them, you can heal them by squatting, by making sure you drink adequate water, by making sure you're having a fibre diet, by making sure you exercise that colon every day, by exercising. And you can even prevent those nasty little things which need not happen. So thank you for your attention on the journey on the gastrointestinal tract. We're going to stop now, and when you come back at 7:30, we're going to go through again, and I'm going to show at every stage how you can bring about healing. If your stomach works too much, we can show you how to slow it down. If your stomach is not breaking down your food properly, we can show you. If your liver's not working well, if your pancreas isn't working well, if your colon's going too fast or too slow, at every stage there are things you can do to heal that. And also, at every stage, there are symptoms that will tell you that it's not working well. So